In this video, I'm going to talk about significant figures, the importance of them, and how to determine how many significant figures are in a given value. So before we get into significant figures, we first need to talk about the difference between exact numbers and measurements. Exact numbers, if you didn't get it from the name, are always exact. It is either a defined number, like how 1 dozen is equal to 12 of something, or how there's 12 inches in a foot, or it could be the result of a count. So if we were to count how many crayons are in this picture, 1, 2, 3, 4, 5, 6, 7, 8, that is an exact number. There is no uncertainty that there are 8 crayons there. So an exact number does not affect the accuracy of a calculation, okay? When you did dimensional analysis, which you should have done hopefully in physical science or chemistry, right? You used conversion factors to go from one unit to the other. Those conversion factors were exact numbers, and they did not play a role in the accuracy of what you got out of that calculation, okay? On the other hand, any measurements you take using an instrument, like if you were to find out how much water you have in this graduated cylinder, or if you were to try to find the mass of something on a balance, those measurements always have some level of uncertainty. When you try and figure out the volume of water in a graduated cylinder, you have to guess at some point the next number in that volume, right? In science, we want to only use the numbers of significance in our values, in our measurements, in our calculations. If we were to try and guess the volume of water in this graduated cylinder to the 10,000th place, there's so much uncertainty in that measurement that our calculation really wouldn't hold any value, okay? So we're going to go over some of the rules to determining significant figures and how you can tell if a digit is significant or not. So the first rule is that any non-zero digits are always significant. So if you ever see any number between 1 and 9 in a given value, that number is always significant. So for instance, 9.6, both of those numbers are non-zero digits, so 9.6 consists of 2 significant figures. And by the way, if you didn't catch on, you don't have to keep saying significant figures. You can abbreviate that as Sig Figs, okay? The number 145,285, all of those numbers are non-zero digits. Therefore, all of those numbers are significant. So that number consists of 6 Sig Figs. The second rule is that any zeros between 2 significant digits are always significant. So for instance, if we look at the number 908, that 0 is significant even though it's not a non-zero digit. So for instance, if you were measuring out how long something was in centimeters, and you got the answer 908, that 0 is significant because you were able to be certain on the hundreds place, okay? And in order to be certain on that ones place, in order to get that 8, you had to be certain on the 0. Same with the number 1005. In order to know that the ones place is a 5, you have to know the hundreds and the tenths place for certain. So therefore, the zeros in between the 1 and the 5 are significant. The third rule is that a final 0 or trailing zeros in the decimal portion only are significant. So you see in this top value here, the 4 is significant, says rule number 1 that all non-zero digits are significant. The 0 after it, because this is after the decimal, is always going to be significant. Even if there are 20 zeros after that 4, all 20 of those zeros, because they are trailing a non-zero digit after the decimal, are always going to be significant. So this top number here has 2 sig figs because the 4 and the 0 are significant. And this number here has 4 sig figs because the 8 and the 3 trailing zeros are also significant. Now there are different types of zeros. The first one are space-holding zeros and zeros to the left of the decimal point if you're looking at a number that is less than 1. The zeros that come before the sig figs, these 3, these are just place-holding zeros, so they are not significant. They have to be there in order for the 4 to be in the correct space, so therefore those zeros are not significant. As well as the 0 before the decimal, that is also not significant. It's just kind of a courteous act to put the 0 there. Otherwise, the decimal point could be lost and people could think it's a period. You just put the 0 before the decimal always as a courtesy. So those zeros are not significant. Some more types of zeros. Trailing zeros in a whole number are also not significant. So in this number up here, 200, the 2 is significant because it is a non-zero digit. The 2 trailing zeros are not significant. Likewise with 25,000, 25 is significant because they are non-zero digits, but the trailing zeros are not significant. If the zeros are trailing in a decimal, they are significant, but if they're trailing in a whole number, they are not. However, you can make them significant by putting a decimal at the end of the number. If you put a decimal at the end of 200, that automatically makes all 3 of these numbers significant. As well as for 25,000, if you put a decimal at the end, it changes the number from having 2 sig figs to having 5. And the way that we usually represent that is by using scientific notation. So for instance, every single one of the numbers on the right side of your screen are all 100. However, the top number has 1 sig fig, the second number has 2 sig figs, the third number has 3, and the fourth number has 4. So it's the same number, they all equal 100, but they have different numbers of sig figs based on the way that they were written. So based on how many sig figs you want your number in standard form to have. Okay, if I have a measurement of 100 and it has 2 sig figs, there's no way to write that in standard form to have someone understand that there are 2 sig figs. If I write out 100, unless you state it that there's 2 sig figs, no one's going to know that there are 2 sig figs. So you have to put it into scientific notation like this, 1.0 times 10 to the second, to express to others that there are 2 significant digits in your measurement. If you only have 1, then you would just put 1 times 10 to the second. If you have 3 significant figures, obviously if the number is 100, you could just put the decimal at the end of the number, or you could write it like this. And if there are 4, you could write it 100.0, or you can write it like this. Either way, the number of sig figs in a number written in scientific notation will be represented in the coefficient, which is this number before the times 10 to the. Now, this might seem like common sense, but I just need to cover it just in case that any leading zeros in a whole number, that means any zeros that come before a whole number, are not significant. I don't know who in their right mind puts these zeros in a whole number, but just in case you see them, any zeros written before a whole number are not significant. So don't count them. They shouldn't even be there, but don't count them, okay? And those are the basic rules for sig figs.